Welcome to Equinox, where Rob and I are striking the balance between the light and the dark. This is episode 44. My name is Joseph Darnell, and I'm joined by my good friend, the doctor on the show, Robert Carter. Hello, Rob.
Hello, Joe. How's your week been, man?
It's been a lot of work.
Okay. Is that bad?
How are you doing?
I'm doing fantastic.
I have been recording more shows. I constructed a desk.
Oh.
I've been fixing some furniture around the house. It's been good though. I really have no complaints.
Cool.
How about you?
Well, I have no complaints either. It's going well. You and I spent 2 hours today recording episodes for our main employer.
Yeah.
Video episodes. But tell me about your desk. What did you do?
Okay, so I've wanted to get a sit-stand desk for a while, and it was high time. So I went ahead and took the plunge.
Dude, I'm jealous.
So I had this old IKEA desk. Yeah, you should be jealous. This old IKEA desk was bowing in the middle just a little bit, and I've had it for going on 7 years, I think. And it wasn't anything great. And I looked into, well, should I get the IKEA sit-stand desk? But I didn't want to drive all the way out there. It's like an hour away. Then I got some recommendations for things online. And then I said, you know what? These are all like $600, $700, $1,000.
Wow.
But if I go over to Amazon, there's some other brands that are not as cool, not as, premium, but they have all the features you're looking for. Like you need like a riser as part of your desk to raise an iMac screen because it doesn't have a swivel neck and you can't raise it.
Okay.
So I need it to be raised up on a platform. And then I also wanted the presets. So I've got presets on this sit-stand desk for 1 and 2 and 3. And they're really easy to use. The brand is called Feasibo, and it's got a rugged wood textured surface on the top and black legs, I really like it, man. It was fun to put together too.
And how much did it run you?
$300 and I want to say $60.
Well, I am entirely jealous.
Which is really affordable for all these features. Yeah, it's a good set.
And I'm thinking to myself, hey, dude, I got a wood shop. And I got YouTube.
Yes.
And YouTube University can teach me anything. And I bet I can look up how to build your own standing desk.
Oh, you so could. And as I looked at all the parts, I wouldn't be at all surprised if you would love making up one of these.
All right.
You would use it for your studio office, right?
Yeah, I just need a standing desk and I could sit somewhere else if I have to.
Oh, yeah.
All right.
Then go for it.
I'm going to go for it.
Well, you've been working on your own office setup and studio. How's that coming along?
It's going well, but it's not really an office because, right now my office is my TV tray. I sit my laptop on my TV tray and I sit in this hard wooden chair I've been sitting on for 9 months now. And when I go into the studio, I just wheel my computer in there and then go grab the chair.
Yeah. But then I have seen your background and those shelves. They look very nice. You even got the accent colors.
Oh, just wait. I ordered some strip LED lighting that you can toggle the colors in different ways. And of course, it's on wish.com, so it's really cheap. And it was really forever to get here. And then they said, oh, we're sorry, we're out of stock. Oh, man. So I've been delaying filming some biblical genetics episodes in my studio because I didn't have that particular lighting. And then, well, it'll get here eventually, I guess.
Now, your lighting looked really good on the video today, and you were telling me about some foreground lights that you were using. Are they just home lights, or did you get a studio light?
I got a bunch of LED lights, like the kind you have in the CMI studio.
Oh, okay.
But they're smaller and less expensive.
Very nice. Well, they're working,
Well, yeah, but it helped today because it was sunny outside, and so the sunlight percolating through the closed blinds gave me a nice side light on one side. It's a lot harder to do this at night.
Oh, nice. Yeah. And even a lot of the other professionals cheat and use the daylight. Don't let that, feel like it's a cheat.
Well, yeah, but I got to work in the daytime. I can't film in the daytime.
That's true.
Except on Saturday and Sunday. Hey, you know those pictures people have where the pictures split up into different picture frames? So maybe like the USS Enterprise is like 5 feet wide and 5 different pictures, and they cost like $900.
Yes.
Yeah.
They're beautiful. I love them.
Wish.com, $26.
For real?
Yeah, so that's going to be part of the backdrop in my studio on one side. And I got some other ideas of things to do. So, because I don't want always the same shot. I want to move the camera a little bit here and there. And so I need other interesting things in that room to reposition cameras in different ways.
Yeah, of course. I was looking at one of these premium Logitech Brio 4K Ultra HD webcams today.
Yeah.
So it's usually runs 200, but there's a sale on it right now at Lenovo, a tongue twister. It's Lenovo.com
Yeah.
for 20% off. It's 160.
All right.
It's like it's the best of the best. It's a really great webcam. I'm really tempted.
Send me a link. Send me a link, because I'm still using my Osmo Pocket, which I love that camera, but inside shooting, it's not the best.
Yeah.
It's really designed for outside stuff and works great outside, but inside it's just really difficult.
Well, and you could potentially use a second cam. You could have one camera one way for the intro or the ending of your video, and then turn the other way to show.
I would look so professional if I did that.
Mm-hmm.
I think. All right, yeah, send me a link, because I could always use an old cell phone, but the little teeny lens is just not really a professional look.
No, not usually. And even by YouTube standards, I know a lot of people are getting by with those when they get started, but you don't want to keep doing it indefinitely.
Plus, I don't have the Apple thing with the 3 eyeballs on the back. I'm using Samsung products and they only have a single lens. So yeah.
Oh yeah. Well, what you do if you're dedicated to Samsung products and that's what you're going to do, then you just buy multiple smartphones and use all the different cameras on all of them at the same time. No, that's a terrible idea.
Sorry, I was trying to think of some snappy comeback and my mouth is hanging open. That is so dumb. I couldn't think of something funny to say.
Though on a technicality, I have ruined so many videos not in my prime, but when I was learning by the School of Hard Knocks, I was filming when I was a teenager, and we were using every camera we could get our hands on. Hey, Dad, your old camcorder, it's half broke. Can we use it this weekend, please?
Camcorders.
We recorded a concert with a really incredible violinist, and it was like 2 hours long, and her pieces were gorgeous. And then we got the footage into the computer, and the internal clock recording speed on all the cameras was different. So none of it stayed in sync. And we were constantly, you know how it's bad when you're just lip reading and you can tell that the lips are out of sync. Well, it was so frustrating to get the motion right of her bow on the violin. Yeah, we had to synchronize it with the movement of her bow. Oh, that was tough.
I'll tell you what, I wanted to quit biblical genetics several times because of that issue. It was partly the camera, partly my computer, partly Adobe Premiere, and things seemed to work out eventually as I learned a little more. But last summer there was an update, and for like a month or month and a half, I did not know if the audio and video would be in sync until after I exported.
Oh, wow.
And it would come out wrong. And so I'd go back and I would slide the audio 5 frames to the left and export again. Oh, wrong way. 5 frames to the right. Oh, no. 6 frames to the right. And so I'd have to export 3 or 4 times, and each one of those takes like an hour. And I was pulling my hair out. So yeah, out of sync issues are the bane of sanity.
Deadly.
Yes. Yeah. Anyway, we don't do video on this show. We do audio.
Well, then following up on the other thing that we wanted to get to before the main topic, you are working on the COVID-19 paper. Do you have any announcement for when it would be published? How's it going?
We have farmed it out to 2 people that we know that are on board as far as our religious viewpoints are concerned. And they're both PhD scientists working at universities. And they both liked our paper very much. They had one concern of one section which we've removed, and we recycled 2 paragraphs and put them somewhere else. But besides that, they're like, go for it. So now we're going to be it's a lot easier to publish if you have a university professor on your team.
Oh, okay.
And I'm not a university professor, even though I have a PhD. And my co-author, John Sanford, he's retired, so he's no longer associated with any university. It's just a lot easier if you have an author that actually is at a university. So we're going to ask someone if they will be on our paper, but that person also has to contribute. So then we have to say, okay, now what can you contribute? What can you do? What can you add to the paper?
Oh, yeah. Something reputable. Endorsement.
But I read another paper today by some guy I'd never heard of before. He's a cancer doctor, and he has the same exact idea that we do. And I mean, I've got different analyses than he has, so we can still publish our paper. But he also included things that I didn't know. And so I might have some more charts and graphs and analyses to add to the paper after I double check his work. And I've been reading that all day long. It's a long
Any
paper.
unique revelations?
Oh, little things like I didn't know that there's a subway line in Wuhan, China that they are calling the route of dissemination for the virus.
Oh.
And that's the subway stop for the Wuhan Institute of Virology.
Oh.
Little things like that. It's like, I didn't know this was a subway. Oh, it's right there. Oh, my. Anyway, more later. I'll leave the audience hanging. I'm not going to say anything more till our analyses are complete.
Well, we're very excited to read it when it's ready.
Oh, I can't wait.
Do you reckon that our listeners would even understand it? Now that I'm
no,
thinking
absolutely.
about it, I'm like, okay. I didn't know what, is it a 5th grade reading level or?
No, not at all, but I can explain it on an audience acceptable level, audience appropriate level.
Oh, very well. Maybe you could do a reading and we can dumb it down for me.
No. Well, first of all, it's 30 pages long. I don't think we want to read it. And second of all, you can't read a chart.
Ah, it's true. It's true.
Yeah.
All right. Well, then let's move on to the main subject.
All right.
You wanted to get back around to something that has been in the queue probably since the beginning, which is radiometric dating.
Yes. And I'm be surprised if we haven't talked about this at all on our show, but we've never done an official, specifically carbon dating episode. And I would like to do that.
This is something that it comes up a lot in our organization when we are teaching around the country science subjects.
Yep.
And it's not something, who would be a specialist? What kind of scientist would be a specialist in the field that is radiometric dating all the time?
Well, a radiometric dating scientist.
So that would be their class. It's not like he's a paleontologist and all paleontologists are radiometric datingologists.
No, okay. Not at all. They take a sample and bring it to someone else. Hey, give me a date on this. Okay. So, physical chemists, geochemists. I'm not sure exactly what branch of science this falls under. Physics, probably physics. But there are people who specialize in these sorts of techniques. And there's all sorts of different ones. It's really kind of funny because I get challenged a lot on this issue based on my profession. And a lot of times someone will stand up in the back during a cute question and answer session and they'll just say, what about radiometric dating? Oh, sorry, no, I ruined my own joke. They say, what about carbon dating? As if, they're going to stump me. And I already know this person doesn't know what they're talking about. And I say, excuse me, sir, you said carbon dating. Do you mean radiometric dating? Like, uranium to lead? And he goes, oh yeah, that. Gotcha. I say, actually, carbon dating is one technique out of hundreds of different radiometric dating techniques. Argon to argon is very important. Uranium to lead is hardly ever used, even that's what people think about. Carbon dating also cannot be used to demonstrate that the Earth is millions or billions of years old. It's only good on young samples. And at this point, the person's mouth is hanging open. They had no idea that would have an answer. And I've already told them stuff that's just ringing their bell. Like, this can't possibly be true. What are you talking about? And so let's spend, 45 minutes or so describing what this is, how it works, what it's good for, how accurate it is. Those are really fascinating questions.
You just said a moment ago that there are hundreds of dating methods. Mm-hmm. Is that just because they're looking at the conversion of a variety of different elements?
Yeah, there's
hundreds of different elements.
Yeah, there's all sorts of different radioactive elements. And like if you're looking at a cave deposit, well, I guess you could look at the limestone, but the limestone is old carbon. There's no carbon-14 in it. So, a stalactite in a cave, you can't use carbon dating on that. Except that there's groundwater percolating through, and the groundwater absorbs carbon-14 from the atmosphere. Therefore, there will be some carbon-14, but you can see that'd be a very complicated test.
Yeah, because you're saying that the water is, in a manner of speaking, contaminating the ratio.
Yeah, so you wouldn't use carbon-14 on something like that. You might use uranium, but the problem is uranium is soluble. It dissolves through things. Ugly. Anyway, forgetting. Oh, another really important one is potassium argon. That's very common. Potassium-40 breaks down to argon-40. Argon is a gas. Potassium isn't. And so you go up to some lava flow, and they assume that while this was lava, all the gas would have boiled off. And when it hardened, that's when the Argon Clock starts. Now, the argon is trapped inside the crystals inside the lava. And so if you pull some crystals out, you can measure the amount of potassium-40, measure the amount of argon, and you can estimate how long this lava flow has been there. That's a gross oversimplification of a very technical subject.
I was going to say, it sounds like it, but very well done.
Oh, thank you. But carbon dating.
Well, wait. I just had a thought.
What? Yeah?
Technically speaking, you said we can only date younger things. We can't date like super duper old things.
With carbon-14, yes.
Okay, can we use something like carbon-14 to date living things? Like, could you date a dog? Could you date me?
Yes, you could. It will say post 1945.
Oh, okay. So it cannot be that precise. Okay.
Well, no, it'll say post 1945 because of atmospheric atomic testing.
Oh.
There's a lot more carbon-14 in the atmosphere now than ever in Earth's history. We produced a massive amount of carbon-14 because of atomic bombs. And so you do something modern and it'll spike the needle on your machine. You say, oh, modern. It's also a problem when you're testing an old sample because it's contaminated with modern air, maybe modern water. So you have to subtract out the modern component and only look at the ancient component. And that is a trick. There's an art to that. You can't just take a sample, stick it in a machine, the machine goes, bing, this thing is 3,521 years old. That's not the way it works.
I picture there's a scientist. He has like a microwave. He just pops it in there and it runs for 3 seconds and tells him he's 300 million years old. Bing! Why do we even need a scientist? We got the age wave.
The machine, just put it in there. Yeah. You don't have to calibrate that machine. You don't have to do anything fancy. You don't have to run it through any mathematical modeling. No problem. So another thing that's surprising is people don't realize how young radiometric dating techniques are. The first attempts. Oh, that's funny. That's kind of an oxymoron, isn't it?
Yes. Okay, continue.
The first attempts at dating things with radioactive breakdown didn't start until the late 1800s. So how old is the Earth? That question has nothing to do with radiometric dating because secular scientists had decided the Earth is billions of years old before we even knew what radiometric dating was. And yet in the late 1800s, we did not have the chemical scientific precision to measure isotopes of atoms down to the level that's required. So really, as a practical science, this didn't start until after World War II. Oh, that's not that long ago.
No, it's not.
No. So essentially what they did is they used radiometric dating to confirm how old they thought the Earth was, which means there might be a selection bias there. It means they might have picked the dating techniques that work according to what they thought is true and rejected other dating techniques that would give them a different answer had they used them. Oh. So there is a lot of art in this science and people don't realize that. There's a lot of assumption and we haven't even gotten to how they actually run the calculation yet. So go ahead.
Well, this raises a couple of questions.
Okay.
For one, why did it take off? And maybe the precursor to that is, why were scientists and people interested in dating old stuff in the first place?
Well, it sure would be nice if you could actually say, we think this thing is millions of years old. Instead, you could say, this thing is 1.125 million years old. Man, that sounds very scientific, doesn't it? That sounds very confident,
yeah,
doesn't it?
I guess it does.
Yeah, you could take your vague statements and say something very specific. And yet, there's so many examples in science where they come down to this thing is X years old with a lot of decimal points. And then later on, oh, that's not true. And they give it a completely different number. One of the classics is the KBS tuff in Africa. There's some famous African hominin fossils found, and they're associated with this ash layer. And, well, they dated them like 3.5 million years old. Wow, look at that. Thing is, no one believes that modern humans evolved that long ago. And so they redated it. And then they redated it. And actually, the dating of this ash layer is based on fossilized pig teeth, not on radiometric dating. Yeah, this is lost on people. So this whole idea that you can just take a sample and get a number out of it is simply not true.
Right. Huh.
All right. So carbon dating is invented during World War II by a man named Willard Libby, future Nobel Prize laureate at the University of Chicago. And what he realized is he could take a Geiger counter and put the counting end inside a sealed box that's shielded, and you can measure radioactivity in a sample. And the older the sample is of like wood or something like that, the less radioactivity there was. Ha! Carbon dating is invented. And he actually used Egyptian sarcophagus lids as his base.
Oh, if you're going to do it, you got to do it with something really cool like Egyptian sarcophagus lids.
But also from a range of dates. And so he said, okay, here's how old the sarcophagus lid is. Measure carbon dating. Okay, here's how much radioactivity it has. He put that on a chart. But what he stated very early on, he said, this is weird because my earliest samples have a bias. They're measuring older than I think they are. And that raises interesting questions. Is Egyptian dating off? Yeah, probably. Or does carbon dating get wronger and wronger as you get older and older?
How would you know? Are you saying they actually couldn't know?
Well, we can't know specifically because we don't have anything historical that goes back to as long ago as they say carbon dating can be used for.
Okay.
We don't have a good Egyptian chronology. We don't have a Babylonian chronology. We don't have a Greek chronology. We have bits and pieces and experts arguing over things, but they argue over 200, 300, 400 year differences. And carbon dating is supposedly more accurate than that. So you can get a date and you get a measurement, but you don't know how old the thing is unless you have a way to calibrate it. And we can't calibrate it to historical samples. We don't have any. What an interesting paradox.
Yeah.
And so one thing they do is
that's really funny about dating in general and anything of historical value.
Yeah.
A few thousand years old doesn't really sound all that old in the grand scheme of things because, 10,000 years old starts to sound old. But then a lot of human history has happened in the last 6,000 years.
Yeah.
And then you got the evolutionists saying that the whole universe is billions of years old. So it's really hard to appreciate these numbers.
Yeah, it is. And it's daunting. And I understand why people wrestle and struggle and waver in their faith because of these things. But part of this episode is trying to tell people that the science is not as certain as some scientists want you to think. One of the reasons why, the single reason why carbon dating doesn't work out to millions of years is because the half-life is only 5,730 years. So after 5,000 years, literally half of your carbon-14 is left. I remember in Evolution's Achilles' Heels, on camera, Jonathan Sarfati said, if the whole Earth was 100% pure carbon-14, there would be nothing left in less than a million years. And he said that on camera. I was like, what? So I got on Google. I said, how many atoms are in the Earth? And Google told me. Okay, so I put that in an Excel spreadsheet, and I divided by 2, divided by 2, divided by 2 until I had one atom left. And then I put 5,730, and I multiply by 2, multiply by 3, multiply by 4, and I got all the way down to when I had one atom left, and it was less than 900,000 years.
Oh, wow.
So, I mean, we're talking about really 100% pure block of carbon-14. In 5,700 years, half of it's gone. In a million years, there's literally not a single atom of it left. It's all decayed into nitrogen-14. It's poof. And when we're talking about carbon dating, we're talking about 1 out of every trillion carbon dioxide atoms in the atmosphere is carbon-14. So how long would it take that to completely disintegrate? About 70 or 80,000 years, maybe 100 at the most. So based on the amount in the atmosphere now, and plants are absorbing that, so therefore plants have about the same amount in the atmosphere. I'll talk about that in a minute. But when a tree dies, it starts to decay, and there's no way, if that tree was pure carbon-14, nothing left in less than a million years. Based on how much carbon-14 is in the atmosphere, nothing less in less than 100,000 years. There's a theoretical limit to how old you can date things with carbon-14. So
that is a substantially narrower frame of time than I think a lot of people are aware of.
Yeah. Now, uranium might have a really long half-life. Fine. Carbon-14 does not. And the fact that we find carbon-14 in every carbon source on Earth, coal, shale, limestone, diamonds. In fact, someone went to the coal repository in Pennsylvania. They have pieces of coal from all around the world. And they took supposedly 30 million year old Miocene coal and supposedly 300 million year old Pennsylvanian coals and everything in between. They measured the carbon-14 in these coals, which is ridiculous. Why would you do that? There's no carbon-14 in anything that old, said the evolutionists. And they came out with carbon dates, and they're all about the same range.
Whoops.
So the Miocene coals are about the same carbon age as the Pennsylvanian coals. Were they laid down at the same time? Whoops. And now, of course, here comes the experts. Oh, no, there's an error here. You can't do that. There's contamination. You're a bad scientist. You don't do your techniques right. And all these ways to try to explain it away. But that was a real scientific result. I mean, even in diamonds are supposedly carbon that was on the surface and brought way down deep, like a mile of depth or more for the heat and the pressure, and then brought back up close enough to the surface that we can mine it. And so, diamonds, a billion years old to make a diamond, 2-3 billion years to make a diamond, and yet they have carbon-14 in them. And the cool thing about a diamond is a crystal. You can't contaminate a crystal. Now, you can make carbon-14, theoretically, in the earth from gamma rays from radioactive breakdown. The problem is, in order to get as much carbon-14 in those diamonds as they found, you would not need any carbon. You'd literally need a lump of uranium. We wouldn't call it a diamond. We would call it a uranium chunk. And there's not that much radioactivity in the rocks that they're digging these out of. So there's no known natural source for carbon-14 in diamonds. Either they're not a billion years old, or something very strange happens in the center of the earth that we can't explain. Yeah, lots of really cool mysteries involved in this. But if you could make carbon-14 in the ground, how does it get made in the atmosphere? And it has to be made in the atmosphere, or else there would be none. There would be zero today if there wasn't a source of it to be manufactured. Do you know where it comes from?
I don't remember. To be honest, this is one of the sciences that makes total sense when it's explained, but it's easy to recall. It's not easy to recall.
Yeah, well, that's true of a lot of science. And if you don't regurgitate it in your brain many, many, many times, it slips.
Yeah.
I mean, I've forgotten a lot of science, but I try to remember as much as I can. Okay, but for this particular one,
you're doing pretty good.
A cosmic ray streaming in from the deepness of interstellar space. We don't even know where cosmic rays come from. We don't know what their source is. Kind of ideas, but nobody really knows. Anyway, high energy cosmic rays, which is really just a neutron, proton, whatever. It's a center of a hydrogen atom, and it zips in and it smacks nitrogen. Nitrogen is a N2 is its form. It's free nitrogen in the atmosphere really doesn't exist. So it's in the form of N2. It smacks that nitrogen 14, creating a carbon-14. But carbon doesn't exist by itself in the atmosphere. It will tend to react with an oxygen molecule, make carbon monoxide, and that will react with a water to make carbon dioxide. And now we have carbon-14 from nitrogen-14 in the form of carbon dioxide. And that's where this whole process begins, because now plants can absorb it. And plants are radioactive.
Yeah, you don't think of it that way.
And you can measure it, but it's only 1 out of a trillion carbon atoms. And there's some fractionation that happens. Plants they pull in carbon-12 much more than they pull in carbon-13, which is another naturally occurring isotope of carbon. And they pull those two in much more than they pull in carbon-14. So you can't even measure the amount of carbon-14 in the atmosphere and know how much is going to be in plants. You have to apply a mathematical model. It's complicated. And so if the carbon-14 in the atmosphere changes, which we know it does seasonally, then how much does it have an effect on the plants? That's still an area of open research right now. And so if you have a plant and you take a sample of it, it also depends on what latitude you are. Depends on how close to the ocean you are. Depends on your altitude. What?
Let's say, it's a lot of variables I would not have counted on.
There's so many variables. In fact, they just did a recalibration of Egypt, carbon calibration curve for Egyptian things, but they based it on northern Mediterranean samples. Egypt is south of the Mediterranean, and the prevailing winds blowing across the Mediterranean, any wind that blows across a body of water is blowing across something that has less carbon-14 in it than the atmosphere. And so if you're downwind of a significant body of water, your plants will be absorbing less carbon-14 than something that's upwind of that body of water. So you want to go and calibrate Egypt based on something on the other side of a giant sea? No, it doesn't work that way. One way they try to do calibration is with tree rings. They'll take an old tree and they'll sample the very minute little ring, and they'll get the carbon date, and they'll go through the whole tree from outside to inside and get a curve. And then they'll say, okay, this ring was growing in 1850. This ring was growing in 1800. This one was growing in 1750. And they'll put those on a chart, and they'll combine many, 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 many tree rings. The thing is, we don't have tree rings that go all the way back to the beginning. We have dead trees.
To the beginning of what?
Of time, whatever, of the carbon clock. We have dead trees, and so they'll core a dead tree and do carbon clocking on that, and they'll try to match up the rings, they'll try to match up the carbon peaks, and that on and on and on. And they've built this very detailed calibration curve for trees. But when you look at it, it's very, very, very peculiar, because you can see a whole bunch of modern samples and you can see a whole bunch of ancient samples, and there's a hole in between, and they can't fill the hole. They can't find any trees that exist in the middle. Like, a dead tree lying on the ground, it's 4,000 years old. They can't find any that are 2,000 years old. I'm making those numbers up. But there's a gap in the middle where they have almost no data and they can't figure it out. Well, what if their assumptions are wrong? What if the amount of carbon-14 in the atmosphere changed radically at one point in Earth's history? And there is definitely a mechanism for this, a huge, very important mechanism that actually controls the amount of carbon-14 in the atmosphere, and that is the Earth's magnetic field. So magnetism and carbon-14 have nothing to do with each other. But magnetism and cosmic rays, which are charged particles, have everything to do with each other. Because remember in our episode, if you have a moving charged particle, it will bend when it approaches a magnetic field. Right? We talked about that like for a whole hour once.
Yeah, right.
Well, as charged particles race at the Earth from outer space, they hit the Earth's magnetic field. This is what produces the northern lights and the southern lights, is those charged particles getting trapped in this magnetic bottle. The stronger the Earth's magnetic field, the fewer charged particles penetrate and hit the atmosphere. And we know.
So what I'm gathering from all this is that if someone wanted to date anything accurately, this seems like not a very substantive way to go about it. I mean, there would be, it's like saying, I want to chop up some, carrots. Let me see. What can we use? I have a pine cone. I'll use the pine cone to chop up the carrots. It's
Yes.
not necessarily a very useful way to go about it.
Well, yes and no. Yes,
so it seems a
and
little bit desperate.
if you throw in all the caveats and all the difficulties and all the uncertainties in one lecture like we're doing now, you get really suspicious. But I'm kind of doing it on purpose because once you get all that out of the way, then you can talk about how accurate it is. And the two case studies we'll do at the end are going to be interesting historical case studies, and we're going to show that carbon dating really does work, at least up through the medieval period. The argument
works up through the medieval period,
Yeah,
or you mean as
yeah.
far back as the medieval?
Yeah, as far back as the medieval period, to the time of Christ, no
Okay.
problem. Time of King David,
Oh,
probably
okay.
pretty good. But when who was the famous archaeologist that first excavated at Jericho? Oh, he's famous. His name is escaping me at the moment. But he looked at Jericho and he said, "This is amazing. This follows the Bible. The walls fell down flat. The city was deliberately burned. Nothing was taken from the city. No one occupied this site for another 500 years. That's exactly the biblical depiction of Jericho." But then Kathleen Kenyon came there after World War II, and she said, "I see no evidence for the destruction of Joshua because the ash layer, the burnt charred layer, was carbon dated, and it carbon dated about 300 years before the Bible says that the Israelites destroyed Jericho." But you remember,
That's just not right.
there's something wrong here. Remember the thing about the Egyptian coffin lids getting further and further off, older than they're supposed to be at the earliest periods?
Right.
Or here we have Jericho, which is historically dated according to the Bible to a specific year, and yet the carbon dating is older than the Bible says it is. Wait a second, what's going on here? Well, the Earth's magnetic field, since we have been measuring it very accurately since the 1800s, it is decaying at a rate of about 5% per century. That's huge. That is astronomical. At 5% per century, you can't go infinitely back because magnets can't get infinitely strong. There's a limit to how strong the Earth's magnetic field can be. And even at its greatest maximum strength, it's not even 100,000 years old. But given a biblical time frame of 6,000-7,000 years old, it can have been decaying at 5% per century and to reach today's value. Because the Earth's magnetic field is a giant mystery. No one knows what makes it. It's not a solid bar magnet because solid magnets decay over time. So it has to be something in the Earth that's moving to produce a magnetic field. But why hasn't it slowed down? Why is it still there? Why hasn't it stopped? It's really a giant mystery. But we do know from measuring it specifically, it's going down at a rate of about 5% per century. So if you start going back to 2000, 3000, 4000 BC, you're talking about a very strong magnetic field, which means very little carbon-14 in the atmosphere, which means that any tree growing thousands of years BC is going to have less carbon-14 in it than a modern tree would. Therefore, it is already carbon older than it should be. So when that tree dies, it already looks like it's 100, 200, 300, 500, 1,000 years old. The amount of carbon-14 in the atmosphere isn't stable. That's another reason why you can't use this to date anything millions of years old. You can't even do it 10,000 years old accurately. And I think that explains the mystery of the trees, the tree rings. You have a whole bunch of really old samples and nothing in the middle, and then from 1000 BC till today, you got tons of samples. Well, I think because the Earth's magnetic field was decaying quickly, the older things look older than they really are.
Okay, yeah, that makes a lot of sense.
I
Well,
hope
and there's
so.
also, all said and done, there's not that many unique elements to choose from. So like, you think about the trees. What is the chances that a dead tree is going to still be around if it's 10,000 years old?
Very
If
little
it died
chance.
5,000 years ago,
Very little chance. Very, very little chance. Even in desert environments, wood breaks down. Cosmic rays destroy wood over time. Those high energy things, they break up the cellulose. So yeah.
Okay, well then a lot of our listeners might be wondering, what about fossils and bones?
Well, excellent question. You cannot date fossils because the evolutionists claim they're
What?
millions of years old. There's no carbon-14 in them, right? Except for dinosaur bones. Yeah, if you
Yeah,
carbon date,
so do they just typically not bother?
well, they don't even bother. But petrified, you can't carbon date because the carbon's been replaced by minerals. Something's been permineralized is not the original material. It's an image of the material. But we have found non-petrified dinosaur bones, and they have young carbon dates. Now, is that because they have groundwater that's percolated through? No, because you can boil off the groundwater. There's all sorts of, any sample from modern times, 100 years old, 1,000 years old, they have to remove modern contamination. So you do that with dinosaur bones the same way. And they don't, they give you very old carbon age, tens of thousands of years old, older than the biblical age of the earth, fine. But it's just a carbon age, it's not the real age. The fact that they have any carbon-14 at all is a strong indication they're not as old as the evolutionists think. But most fossils you can't carbon date because of permineralization. Limestone has very little carbon-14 in it, almost none. It has some, but almost none. And therefore, calcium carbonate is a very common form of petrification. And if you infuse a bone with calcium carbonate, you're infusing it with something that's old carbon-wise. But see, it's a problem on the surface too, because you go to Florida, the water in Florida has been percolating through limestone. The water in Florida is older than the water in other places of the world that don't have limestone. As in, if you took a sample of the water and carbon dated it, the Florida water, any limestone area in the world, the water looks older than a place that has granite or something like that. Weirdness.
Yeah.
And therefore, the trees that are growing in Florida and other places with lots of limestone are absorbing carbonates, or some of that carbon is converted to carbon dioxide, which is absorbed by the plants, or the bacteria take carbonates and make it into carbon, and then somehow the plants suck that out of the soil. So you might expect that a tree growing in Florida will be carbon older than a tree growing up here in Georgia on volcanic rocks. This is cool, weird, crazy, complicated, and your brain spins.
Yes.
Hey, did you know that southern hemisphere, the atmosphere is 40 years older than the northern hemisphere?
The atmosphere?
The carbon age of the atmosphere is about 40 years different because there's so much more ocean in the southern hemisphere than in the northern hemisphere. There's more exchange of carbon between the atmosphere and the oceans in the southern hemisphere. And because the oceans have very little carbon-14, the age of the atmosphere in the south is less than the north. They're the same age, but if you measure the amount of carbon-14, one looks older than the other.
Right.
See, the oceans are critical. They are critical. It takes time for carbon dioxide in the atmosphere to get into the oceans. And the oceans are huge. And there's a lot more carbon in the ocean than in the atmosphere. I don't know, 1,000,000 times more, 1,000 times more. I don't remember the number, but there's a lot more carbon in the oceans as carbon dioxide, as calcium carbonate, as carbonic acid. Therefore, the little teeny 1 out of a trillion atoms of carbon dioxide in the atmosphere, as it slowly mixes in with the ocean, first of all, dilutes it. Second of all, there's plenty of time for it to break down. That's also a problem. Okay, I'm going to take one of my case examples and I'll move it up here because I want to talk about this now. There's been a debate for a long time, and it's a very culturally sensitive one, it's politically a difficult one, and that is, what was the origin of the disease called syphilis? Did it originate
what does this got to do with
did it originate in the old world and the European conquerors gave it to the Native Americans? Or did it originate in the New World and the Europeans caught it from the Native Americans? Yeah, that's politically sensitive territory. And so people have been arguing about this a long time. When you die of syphilis, you can tell. You can look at the skeleton and you can see the bones are riddled with holes.
Ooh.
People get these permanent, oozing lesions on their skin. Yeah, that goes all the way through to the bone, and the bone gets eaten away. It's awful disease. And if we look in Europe at skeletons, we see syphilitic skeletons. You can tell. And they found some in Portugal, and they say, oh, these are really early. Let's carbon date them. And they carbon dated prior to 1492. Therefore, syphilis was in Europe before we discovered the Americas. Haha, see that? We gave it to Native Americans. Yeah. No, not so fast. These people lived in a seaside village. Most of their diet was seafood, and the carbon in seafood is carbon older than the carbon in a cow. They had to recalibrate the skeletons based on their diet, and the recalibrated date was post 1492. Aha, see that? We got it from the Native Americans. And what a giant brouhaha. But can you see how the art applies there? The science isn't that straightforward. You have to apply a model, and you have to know a lot about the history of your sample. You can't just get a number. It doesn't work that way. Now, we know that there was a yaws. Yaws is syphilis in Africa. And it's not necessarily sexually transmitted in Africa either. It's the same sort of a bacterium, same genus, maybe even the same species. It's a different mode of action. And in the New World, there's another syphilis-like thing that was really common, and just about all the Native Americans would get it, and they get a little rash at like 3 years old, and it would go away. But it was a cousin, if not the same species. I'm not exactly certain because I don't think it exists anymore. But we know there was a syphilis-like thing here in the New World. And we know that syphilis got really common in the Old World after Columbus. But they have discovered, specifically at one particular couple hundred years prior to 1492 in England, they're excavating an old churchyard, and they're finding people who have syphilis-like skeletons. They don't know if that was a one-off epidemic. They don't know if it's really a syphilis. They don't know if it's the same species, the same type of syphilis. They're not sure, but it looks like that bacterium existed in England way before Columbus. And so again, we flipped the dial in the other direction again. And the science here has gone back and forth 3 or 4 times. It's really funny to watch it happen. All right, so how do they measure carbon-14? In the old days, they use a Geiger counter, which wasn't super accurate. And then they use a gas scintillation counter, which is more accurate. But today, we use an accelerator mass spectrometer.
When you say they weren't super accurate, do you mean that they would have inconsistent dating results, or that they would have just had a broader...
The error bars were larger. You still get the same ballpark, but you'd be, plus or minus 200 years instead of plus or minus 10 years.
Yeah, okay.
So you run a whole bunch of samples, and you could get 800 counts, 900 counts, 700 counts easily. And literally it was counts. They would like ping, 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 ping on a Geiger counter, but not nearly that many. You might get 50 pings in an hour, and you run for a couple of hours. That's how they would do it. But today they use mass spectrometers, accelerator mass spectrometers. So you take your sample, I think they flash ionize it with a flame, and they run it through a spectrometer that measures ratios of the different ions, of the different isotopes. And they've got it that they can almost measure down to single atoms. It is unbelievably amazing how accurate these machines are. So it's not a question of how much carbon-14 is in the sample. We know how much carbon-14 is in the sample. We know carbon-12, carbon-13, carbon-14 almost perfectly. These machines are stunning. But the problem with the machines is, because they're so accurate, now we can go back and measure things like old coal and diamonds and things like that. And the amount of carbon-14 we're getting from these old samples is way above the minimum threshold for the machines. So there really is carbon-14 in every carbon source on Earth, which is a strong argument against an ancient age of the Earth using carbon dating, using a specific radiometric dating technique. It's really there. And how they can explain it in the future, I don't know. But I kind of just laughed because I just know how important it is that it's actually there.
So basically, there isn't anyone who has an explanation for now.
Not for now. Well,
some people think until they get around to.
Yeah, some people think they have an explanation, but when you really analyze it, it's just hand waving. Now they're gonna. If anyone ever hears, "Oh, Carter, you idiot! I can't believe you're saying this stuff. You don't know. You're not a carbon scientist. What do you know?" Blah blah. Okay, fine. But it is pretty easy for scientists to spot hand waving, and this is what we see when they try to explain the results away. So it's not a question of how much carbon-14. And the accuracy, I mean, you can get down to plus or minus 80 years in something that's 1,500 years old. So if some new archaeological excavation in France or something, and they're digging stuff up, it's like, is this bell beakers? Is this linear ceramic? Is this Cro-Magnon? Is this Neanderthal? Is this, Roman? we can know because they can take a carbon sample and they can get it down to within a century pretty easily. Especially applies to the more recent it is, the more accurate it is. But again, it's not perfect. There's another example. My last example I want to bring in is Richard III. Now, I had heard about the story of Richard III, and then I had the pleasure of seeing Richard III. Of course, he's been buried now, but I went to the place where they found him in Leicester. That's Leicester, not Leicester. It's Leicester, as the English say, just north of London. CMI has an office nearby. One of our speakers lives in Leicester. When I went to stay with a speaker for a couple of days, he and his son and I, who's a history buff, we walked around the town talking about all this cool history, and he brought me to see Richard III, whose body was lost. See, he was the last of the Plantagenets. During the War of the Roses, he was the last king on the losing side of the War of the Roses. The modern ruling family of England comes from the winning side of the War of the Roses. Richard III, Shakespeare said he had a bent back in his play, Richard III. And the Richard III Society, descendants and friends of Richard III, and today they're like, no way, that's not true. That's just spurious. He's just gossiping, rumor mongering. Well, they kind of figured out where they thought his body lay. We knew that after the Battle of Bosworth in 1485, that he was hurriedly buried in a church that no longer exists. And if he was buried in a church and he was the king, even though, he's losing side, he was still the king. So they probably would have buried him near the altar, at least in one of the side chapels, but probably near the altar. The guy was a king. Important people get buried near the altar. And yet the church was gone and there was a bunch of buildings and a parking lot. And so they start thinking, and they say, well, we think he's about here. And it just so happens that the parking lot was lettered, or each spot was lettered, and there was an R. And right underneath the R, parking spot R, was the body of Richard III. And he had one of the worst cases of scoliosis that I've ever seen.
Ooh.
His back was an S. He should not have been wielding a sword. Now, he's a great tactician. He was a good military leader, but he couldn't swing a sword. The guy had one shoulder's like a foot higher than the other shoulder sort of problem. And, well, he was not just killed. His head was chopped up. His pelvic region had sword wounds, meaning they shoved a sword up his bum. It was nasty. And he was buried, and they found him. And they did all sorts of really cool things. Like they sampled the soil around his stomach, and they found eggs from a parasite.
Ooh.
Yeah, a parasite you get from eating undercooked beef. And the parasite lives in your liver or your bloodstream, and it swims to your lungs, and it penetrates your lungs and swims up your lungs. And you say, and you swallow it down, then you poop it out. Gross.
Yeah.
Ew. And yet this king had that parasite, and so they carbon dated him, and it turns out to be the wrong date. And it's saying, wait, this is not possible. He's got the scoliosis. He's in the right place. Right, everything is correct about everything in the story. The whole story is correct, except for the carbon date. And then they said, oh, wait a second, silly us. He was the king. He didn't eat chickpea porridge all the time. He ate beef. And animals have a different carbon-14 age than plants.
Oh, okay.
So they recalibrated the sample based on the expected diet of a king. And plus or minus 50 years, he was spot on.
That is incredible.
Well, I'm laughing because the perception is that this is such an accurate science that you can know anything. You can always know the exact age of a sample, and it is simply not true. If they did not know that skeleton was the king, and they did not know the expected diet of a king, they would have claimed it was a completely different individual. You can't tell the person's a king based on a skeleton.
Right.
Cool, huh?
Yeah, it's very interesting. So yeah, you take somebody that we don't know anything about that has, we have their remains, and it's supposedly 800 years old. If we didn't know those conditions, then our date would be thrown way off.
Yeah, and it happens all the time. You can't go to Jericho and take a piece of wood and carbon date it and tell how old that piece of wood is. You have to assume X, Y, and Z. You have to have a calibration curve. You have to have known historically data samples from that region. And something else happened, and this is strange. after the Ice Age was over, or as the Ice Age is ending, which I believe is post-flood, but even given the evolution is 10,000 years ago, fresh water, so much fresh water sheeted across the Mediterranean Sea, it became a freshwater lake. And sometime in the early historical time, that the Mediterranean Sea turned over and became salt water again. And that dumped a massive amount of very old carbon into the atmosphere, and anything downwind of the Mediterranean would have gotten a massive dose of old carbon. It would have messed up the carbon clocks. And what's downwind of the Mediterranean for half the year? It's Egypt and Israel and Greece, depending on which way the winds are blowing.
Mm-hmm.
So the most important archaeological sites as far as history is concerned are contaminated. How do you put that into a model? You have to assume it happened at some time. Okay, from here on back, we're going to subtract this number. But from here on forward, we're not going to subtract that number. There is a lot of user error, shall we say. A lot of, I used the term art a couple of times. What else can we say? That je ne sais quoi, that little bit of I'm the expert, I know what I'm doing, sort of a fudge factor sort of a thing. And that is inherent in the technique itself. So that's the end of my carbon dating soliloquy. What do you think?
Yeah, incredible. Very good. Thank you for hashing out those details.
That's a lot of fun.
It is a lot of fun. So I have a question to ask.
Yeah.
What do you think is or do you know, or would you have a good guess of what the oldest dated thing is that we know that is a fairly accurate date, that has a fairly accurate date?
I know of nothing. A Roman fort, because we know when the Romans were around. King Richard III.
Okay.
The thing is, the further back in time you go, the more suspicious I become of the dates.
Yeah, exactly. I mean, yeah, and you made that very clear. So I was just wondering if you could put a finger on something that would be an exception, or that we felt fairly confident about, like, because we knew of these historical events in 300 BC, then we could say this was so.
I don't know. That's an interesting question, and that's something now I'm going to have to start cataloging. Things that are been carbon dated and they nailed it, and it matches history and it matches the carbon science at the same time. But the thing is, again, that's not the way it works. They run it through a giant algorithm to get a date.
Right.
And so really does history match their algorithm is the question. And if it doesn't, they change the algorithm. Oh, we forgot to subtract 3, or we have to multiply by 1.022 because, the tangential curvature of the thingamajiggy is affecting the things in a non-algorithmic passage. They make up all these.
Right.
Yeah. Think of turbo encapsulator.
Yeah, that sounds really scientific. I'm a little offended now, having heard your explanation for the last hour, that you'd call this a little bit of an art, because I think art is better than that.
No, this is a good art. It's an elegant art. It's a beautiful science. It's a puzzle. It's amazing. You just can't use it to date Jericho.
Yeah, no, that makes sense.
I think you could probably, if you found some, date pits from the time of King David, they're going to date, with all the assumptions that you can make, they're going to be plus or minus 100 years. If you knew everything about the history of that area, you'll probably get down to plus or minus 10 years, 50 years.
Oh, wow.
But within a century is about what you would get. And there's still a relative thing too. If you go into some old city and you sample the top layer, the middle layer, and the bottom layer will have an older carbon date than the top layer. This is true. So there's still a relative, you can still put things in time in order, but you can't necessarily do a city in Turkey and compare it to a city in France. That's not, you can't do that, but within one site, you can still put things in order.
Well, very neat. Good job, Rob.
Well, thanks, man.
Thank you. So thank you, everybody, for joining us on this subject in its quest. If you found this episode interesting in any way, please consider sharing it with your family and friends. And if you want to dig deeper into the topic, we have some show notes for you. All this stuff is on the website for our podcast. That's available at nightowl.fm/equinox/44. The show notes are also with this episode if you subscribe to the show in an app on your phone. Or actually, we don't include the show notes on the YouTube channel. We don't mention the YouTube channel very often, but we do have a few listeners there. Hey, everybody. I'm glad you're enjoying it over there on YouTube.
Yes, thank you much.
And you should also check out Biblical Genetics on YouTube. That's Rob's other project.
Yes.
Biblical Genetics is also available on social media. So that's YouTube. It's got its own website, Biblical Genetics, and Facebook, and where you can watch the videos and join the discussions in the comments.
and MeWe.
Oh, over in MeWe too, yeah.
And I just started a Gab account. I don't know which one I'm gonna do now. But can't be on 4 social medias at the same time. But I just started a Gab account, and I'm thinking of putting my videos on Gab as a channel.
How is that spelled? Is that GAB?
GAB.com.
Oh, we're going to add that to the show notes just this week. So you can find that on Facebook and YouTube and Gab and MeWe and biblicalgenetics.com and watch those videos and join in the comments. And if you want to find me, I'm at JCS Darnell on Twitter, or take a listen to my other podcast, Hi-Fi, which is available at nightowl.fm/hi-fi. It's not about high fidelity audio, it's really just a technology podcast. Until next time, goodbye, Rob.
Goodbye, Joe.
You have been listening to Equinox. Good job. I knew the material would necessitate you'd have to, it would be pushing the limits of our running time. So I didn't want to jump in, interject, and add too many comments. But I did like what you had to say.
And I did talk about, but see, now I'm all messed up because when someone asks me this at a church, I'm going to have to take an hour to answer it. I don't have a 30-second answer anymore. Now I have an hour answer. Oh, man.
Well, and you could say, well, be sure to listen to my podcast with all the nitty-gritty details.
Yes, yeah, I can do that. Someone needs to do, you know what? That needs to be an article on creation.com.
How so?
Well, it's the history of carbon dating, the assumptions of carbon dating, the limits of carbon dating, a couple of case examples of carbon dating.
Oh, yeah.
And we don't have that article. That was almost like a Wikipedia article from my head. all the stuff that I've been accumulating for a long time. I just kind of did a mental spill of all the things I'm thinking about with carbon dating.
You know, that has been something that I've wondered about from time to time with creation.com is it would be handy if there was, I know it's impractical, but still it'd be really fun to dive into something like a wiki that pertains to our subjects from our worldview, covers our history, a glossary of the terms, because all of our articles do a really good job, but they're articles, you know, they're making a pitch. They're addressing one subject.
Yes. We've had multiple web developers have looked at our site from an SEO perspective and have told us that we need landing pages that spider out and connect all the other articles.
Oh, okay.
Like there needs to be one on natural selection, what it is, who invented it, the limits, and here's a bunch of, link to articles, sort of like a wiki page. A Wikipedia page on that, on genetic entropy, on carbon dating, speciation.
We have the daily article that's a step in the right direction.
Yeah.
But I would love it if there was like you're saying, a splash page that was updated at least weekly. That would just say, hey, here's something for you to read.
But imagine you go to creation.com, you type in carbon dating in the search box.
Mm-hmm. What
happens? You get a bunch of articles that mention carbon dating.
Right. Mention it.
And it might even be the Radiometric Dating Q&A, but you don't get, this is carbon dating.
Right.
That should be the top hit.
In my earlier years, when I was learning more about politics, while I was, old enough to vote for myself, I thought, man, why isn't there a website that just presents to you sort of like the rap sheet on every politician that is in office, a wiki of the politicians. So, imagine like if it was the report card for the baseball players, give me their scorecard, tell me all their homers and RBIs and over all the years, which way did they vote? What states have they been in? Who are their friends? What is their history? But just that doesn't exist.
Yep.
So most of the voting is shots in the dark and in bad impressions.
Yep. You know what else I want to see? I want to see a Washington ripoff site where it tracks every vote in real time and allows polling in real time So you could take a college class and they could pretend that they're the Congress and they're voting on the same exact thing the senators or the representatives are voting on.
Oh, that'd be cool. Yeah.
Or you could take, a nationwide poll. How would the nation have voted on that committee? They wouldn't have voted for that. They would have, voted on this side, not that side. So every little committee vote, every floor vote, every voice vote, every roll call vote in real time with polling, that'd be cool. And I think the Congress people would not like it. Oh, you just don't understand how how X, Y, and Z works, and blah 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 blah. I think what would happen is we would constantly be voting against raising any taxes.
Yeah.
Because we don't need Congress anymore.
No.
We could literally do
Imagine a civil government where all the voting was done over our phones on something like a social network.
Yeah, and 10% of the people would actually participate. But 10% of the people is a lot more than the number of people in Congress.
Oh,
anyway,
yeah.
Maybe we should make a fourth branch of government. We the people.
Oh, that's how it should be. Yeah.
Yeah.
I like that.